Hi. Following the previous video about negative numbers, I'm decided to continue this video with fixing some, at least learning how to improve the operations over negative numbers. So if we look at what we had last time, we tried to divide minus 128 by 2. Okay. Problem was that surely the division is wrong. I start making some numbers, and minus 118 divided by 2 is not 69, it's 59. I was mistaken in the previous video. And our attempt right now, is to fix that problem. Okay. How do we do that? If we notice that one of the main problems by shifting right this number is that the moment that this value goes to the right, and here we have the 0, it turns to a positive number. And obviously the positive representation of that number is not precisely the number divided by 2. So the best solution for this problem is that if we know that we are representing the number in a negative representation, is to turn it into a positive number, execute the operator, and put it back into a negative number. That's the best process to do this to solve this problem. And that can be done by doing this. We have the number up there, and we have a logical operator, if we remember, that is and, in this case, and, or XOR, okay, or not, which is eventually is the negative of and. Well, it's turning the number upside down, right, the inverse. If we apply not to the number AL, yes, we will get it, we will get the complete opposite number of that. It will be plus 118. It should at least work like that. We can even try it. Let's take this out, and let's tell him that we want not AL. I'm not absolutely sure if this will compile, because it will compile. Not AL will turn the number around. It will put where there is a 1 a 0, and when there is a 0 a 1. So we can start, and then we'll get 117, because it is the symmetrical upside representation of the number when we turn it to the other side, because it's in total, when in negative numbers we get to minus 128, and in positive numbers we get to 127. That's the range we have with signed numbers. So the trick here is not really applying not, but applying and. Okay, AL 0 1 1 1 1 1 1 1 B. Okay, what will happen here is that it will respect all these parts except this one, which it will turn it into, it will take out the signed representation. That's the idea of making an and, where the place where it is a 0 will turn it into 0 here. So if we execute, we'll have number 10, which is right, because the representation of this number here is 10. Okay. Now, there is a small problem with this. Again, dividing this number by 2 is not the real solution. Yeah, right? So between choosing and not, the true solution is choosing not, turning it into its negative representation, adding one number. I think we have the option increase, if I'm not mistaken. We increase the number by 1. I think if we put this, let me be sure, yes. And eventually we will have the negative representation of the positive representation of the negative number. Okay, and now we can safely shift right AL by 1, which will divide it, and we will have the value 59, and eventually again turn it into the negative representation of the number, which is eventually doing exactly the opposite to the before phases, not AL, and it should be decrease by 1. We'll test it until to this point to see if everything is going right. We divided 59 and we have to get to the negative 59. So yeah, so no, it's again increasing AL by 1. We want to get to negative 59. So eventually we'll have minus 59, which is really dividing the negative number by 2. Now, as you can see, it's a bit messy and complicated, but eventually that's how the system works behind the complex programming languages. In the following video, which will be the last, we will talk about how the flags work, and well, it won't be the last. In the following video, we will talk about the flags and interruptions, how we can interact with the app itself.